Problem 5, I just want to change in general. So problem 5 says, how does the graph compare to the original parent function? Now, just so we know, the parent function would be log base 4 of like a regular x. There would be no other extras. So we can do that, okay? This minus 3, you should know from previous lessons that that means right 3 because it's with x. This plus 4 would be up 4. Honestly, if you get that much, that's actually pretty great. We don't need to develop a crazy graph. If you want to, I'm more than happy to do that for you. But I think what's really important for us to talk about is what the domain and the range would be of this particular function. So for logarithms, let's just make a rule. For logarithm graphs, the domain is usually x is greater than 0. But I'm going to put a star by that because it's not all the time. However, the range is y equals all real numbers. But that one, there's no asterisk or anything. The range is always y equals all real numbers. Now, if the graph moves left or right, so I'll say if left or right, this changes. I'll count to 5 in my head because I know I write really fast. So if it moves left or right, this changes. Well, this graph did move right, didn't it? And you see up here how we have this right of 3. I think it's important that you realize then that this is no longer 0, it's 3. Because if you move, think about 0 moving to the right 3 units, you're going to land at 3. So instead of the graph coming and approaching like, I don't know why this graph looks silly, but instead of the graph coming and approaching 0 like it normally does, like that, it's going to come over and it's going, well, I'm just going to leave that alone. It's going to come over and it's going to go, instead of a 0, it's going to approach 3 like that. Okay? So it's important that you're able to be able like pick out a multiple choice that looks like it actually got moved to the right 3. The up 4 does not affect your range because all real numbers is all real numbers. The other thing I want to do in this problem, and this is kind of like, again, I'm not doing exactly what the problem wanted, but I do know what I need you to be able to do. I want you to be able to find the inverse. So watch carefully, please, please, please. This is very important. The inverse will switch x and y. So it will be x equals log base 4 y minus 3 plus 4. And now we have to get y by itself. So we're going to minus 4 x minus 4 equals log base 4 of y minus 3. Now we have to untrap y, so we have to switch it to exponential form. So my base is this 4 that I highlighted. I'll highlight it in yellow. So here's my base of 4. This becomes my exponent, x minus 4, and that will equal the y minus 3 that was trapped. So if I color code that, I have, let's see, yellow is yellow, pink is pink, and brown is brown. The last thing we need to do is add the 3 over, and my inverse equation will be 4 to the x minus 4 plus 3 equals y. That's my inverse equation. Compared to the domain and range, they switch qualities. So over here, the range was all real numbers. So this time the domain is all real numbers. See over here? That switches. And the domain was greater than 3, but now the range will be greater than 3. And that's how you take a logarithmic and you change it into an exponential inverse equation.